Okay, Bismillahirrahmanirrahim. Assalamualaikum. So what I'm going to give today is the step 12 in ISH553, establish the monitoring system for each CCP. So previously we have covered the validation of critical limits, or how to decide how to create the critical limit. So I hope you manage to identify step 2 to check for critical limit or to validate the critical limit. Okay, so now for step number 12 is the establish monitoring system for each CCP, or we call this as the principle number 4. Determination of monitoring system for each CCP. A monitoring system shall be established for each CCP relative to its critical limits. So whenever you already decided the critical limits, you need to assign the monitoring system. Okay, monitoring system. So the monitoring system shall consist of sequence of plan measurement. Okay, sequence of plan measurement. Maksudnya ada step by step lah, sequence of plan measurement or observation to detect loss of control at the CCP, because we would like to see any deviation towards or at the CCP, critical control point. So we have assigned the CCP, and then at the CCP we have assigned the critical limit. Now is the process to do the monitoring system to make sure the critical limit is not deviate at the CCP. Okay, so the monitoring system with the necessary monitoring instruction shall comprise the following. Okay, what happened during monitoring system? Number 1, what is being monitored? What is the product, or what is the component? What is the machine? Example, let's say cooker, or the what? Example, the pasteurizer or retort processor. Okay, or the pH meter. So that is the component or the equipment. Number 2, how you're going to monitor. So let's say the pH meter, you're going to check the pH. Okay, the cooker, you're going to check the temperature or the time. Okay, the retort processor is the pressure, contoh. So that is how. Okay, and then number 3, monitoring frequency. How frequent you need to check, or how frequent you need to monitor. Is it every interval, every 30 minutes, or every batch coming? Let's say the raw material, you need to check the every batch coming for the pH or the temperature of the raw material. So how frequent you need to decide. Number 4, personnel responsible for monitoring. Who going to check or who going to monitor the CCP? Okay, personnel responsible for monitoring and evaluating the monitoring result must have the PIC, person in charge. Let's say the for raw material is the purchasing officer or procurement officer. Kena ada khas, tak boleh main pas-pas baton. Okay, hari ni kau, hari esok aku, tak boleh. Dia kena ada specific PIC, purchaser. Or the cooker, the pressure cooker or retort processor is the production staff. Kena specific whom, nama dia. Okay, so that bila if there is any deviation, we can find the PIC to understand or to identify the sources or the causes of the deviation. Okay, the error. Okay, so continue. Where relevant, the location of the monitoring should be recorded. Okay, the location of the monitoring. Where is the location? Is it in the cooker room or packaging room or the storage room or in the container? You need to monitor the location, or you need to be specific the location of the monitoring. The monitoring method and frequency shall be capable of identifying any non-conformity in time of the product. Okay, to be controlled and isolated before it is used on consume. Okay, so monitoring result shall be recorded. Okay, you need to record it. You use the template. How to do is using the template. And where possible, process adjustment should be made when monitoring result indicate trend towards non-conformity. Okay, so let's say if there is a deviation, you need to do the, or we call it as a non-conformity. Nah, sama lah tu. Okay, so let's say if I said a deviation, it show that there is a non-conformity. And what happened, you need to adjust it. Adjustment should be taken before a deviation occurs. Non-conformity, and then you need to adjust, or perhaps you can do the corrective action. Deviation ni actually similar to non-conformity lah. So if there is some error, we call it as a error, non-conformity, or the deviation. So kalau kata ada contoh non-conformity ataupun ada menunjukkan ciri-ciri non-conformity, you need to adjust as soon as possible. So untuk mengelakkan NCR tu proceed or deviation to occur. Okay. Alright. Establish a system to monitoring each identified CCP. Okay, you can see here the previous template. We have finished until the monitoring. We have finished until the critical limits. Now we're going to see the example of monitoring. Okay, receiving of prawn, raw prawn. So the hazard is chemical. Critical limit is the LOG. Okay, consists of chloramphenicol or not detected. And then, okay, the monitoring. What to monitor the LOG or COA? How? By visual check the document every time. Okay, so frequency, every batch. If let's say there's a raw material coming, you need to check the LOG by visualizing it or check visually. Every batch coming, by whom? The store supervisor. So this is the example of monitoring system, monitoring process. Number 2, cooking. Okay, what we're going to monitor the temperature by how to monitor reading from the cooker temperature gauge. So you just read the temperature coming from the cooker. And then how much is the frequency? So every 30 minutes. By whom? The production operator. So how about freezing? Okay, CCP number 3. The critical limit should be below than -22. So what we're going to monitor the temperature? How? By reading the freezer, from freezer temperature gauge every 30 minutes as well. And then production operator. Okay. And finally, example CCP number 4, metal detecting. What to monitor the metal detector? So the process, how? Using the test piece. Boleh check lah macam mana rupa test piece ni. Boleh Google. Okay. And then frequency start of production and every 3 hours. Nampak tak dia punya jarak masa jauh. Okay. Every 3 hours. By whom? The production manager. Okay. Production manager. Sorry, production operator. Okay. Maybe kalau boleh specific by whom lah. Production operator. Nama dia siapa. Okay, so basically this is the monitoring method in the Haccp. So I'll show you some example of equipment in the monitoring system. Like as you can see here, the temperature and pH probe. So here is the pH probe. So you put your liquid in the pH probe, then you can read the specific the pH. Before you use this pH meter, you need to calibrate it first. Kalau you biasa guna dalam lab, you tahulah. Masukkan dulu dalam acid and then alkaline. You set the what we call kita panggil control. So barulah dia boleh baca. Maksudnya kita calibrate dia dulu. Okay, kalau masuk dalam acid, pH dia sepatut turun kepada 3. Masuk dalam alkaline, pH should be 6 and above. Contoh 7 or 8. So then baru kita masukkan dalam kita punya sample to get the specific pH of our product. Next, the temperature. You can use this handheld temperature. Handheld thermometer. Ni boleh cucuk terus dalam kek atau anything lah, chicken ke, meats ke. Similar to this one as well. So yang ni you boleh cucuk, yang ni you boleh just dip in the liquid form of the food. So temperature and pH probe. Okay, what is this? As you can see, the left one is the retort processing. So what is the retort processing? This is the what we call the most advanced method in order for you to produce a zero microbes or zero pathogen bacteria. Contoh macam kita buat contoh kita buat food in can, tin sardin, ataupun apa lagi, Brahim's nasi goreng kampung. So bila you dah packagekan dia or you put in the can, then you place in the retort processor ni, dan dia tutup, and they will set very high pressure or under pressurized environment and very high temperature. So this temperature will kill all the bacteria inside and outside of the can or the packaging. So that's why all the food, ready to eat food, can last longer, perhaps around 1 or 2 years. Okay, this is the reason, the retort processing. Ni. Another one is a fermenter. Okay, I've been using this one during my master. It's a fermenter, or we call it a bioreactor or lab scale bioreactor. Inilah tempat kita buat yogurt tu. Tapi dalam dekat Yakult tu dia besar lagi lah, dia very higher amount. Kalau yang ni 1 liter saja. Kalau yang dalam kilang tu yang macam buat air yogurt tu, maybe dalam 1000 liter. Very large. It equal to a medium size room. Besar dia punya tank ni. Tapi yang ni besar meja je, boleh letak atas meja. So this is what we call a fermenter for lab scale. Okay, so you can put your milk here, you can put your good bacteria inside, and then you ferment it for maybe around 24 hours, and then you're ready to drink the yogurt drink or yogurt juice. Okay, so basically the equipment is considered as the things that you need to monitor. Okay, step number 13, establish the corrective action for deviation of critical limit that may occur. So after we have done the monitoring system, now is the 13th step number 13, to establish corrective action for deviation of critical limit. Kalau tadi kita dah monitor, let's say there's an error, there's a non-conformity, so you need to do the corrective action by, determination of corrective action for each CCP. For each CCP, specific documented corrective action shall be established to be applied when the monitoring results show that a CCP deviates from the critical limits. So this is the definitions. Let's say there's a deviation at the CCP from the critical limit, deviates from the critical limits, you need to do the corrective action. Corrective action shall ensure that the CCP is brought back into control and that product manufactured while the CCP was out of control are handled according to the procedure established for controlling the non-conforming product. Okay, what happened during a corrective action? Number 1, you must ensure that the CCP is brought back to control. Kalau kata dia deviate, contoh cooking sepatutnya 100 degree but deviate into 70 degree. So what should you do? You must make sure the CCP is brought back into control. And then the product manufactured while the CCP was out of control are handled. This is number 1. Brought back into control the CCP. Number 2, the product manufactured while the CCP was out of control are handled according to the procedure. Number 2 is handled. Satu, kita nak okay, first thing, corrective action have to. Number 1 is you need to brought back the CCP under control. Number 2, the product. How do you handle the product? Dua ni penting during the corrective action. So, let's say a cooker, 100 degree, drop down until 70 degrees. So, the first step, you ask the engineer to repair the machine. Second, you need to configure the product, how to manage the product. Adakah kita nak biarkan saja dalam cooker, ataupun you need to ask lah, like what I have discussed with you before. Ask the engineer whether this error can be done, can be repaired within 1 hour, 2 hour. Okay, let's say he said, oh, it's a major error ataupun major repair. So what you need to do is to handle the product, okay, according to the procedure established for controlling the non-conforming product. So let's say dia kata it will take around 2 days. So you need to be hurry, ataupun as soon as possible you have to manage the product. Maybe you kena masuk dalam chill room, or maybe you need to use another cooker, another method, or in order for you to cook the food. So basically 2 things you need to focus on. First, the equipment, how to repair, to make sure it under control, to make sure it not deviate the CCP, to make sure it not deviate this critical limit. And number 2, about the product, what should you do with the product. So that is major activities during the corrective action. Okay, so establish corrective action, pre-plan written procedure. This is what you need to do. Because you're going to provide the Haccp plan. So kenalah ada pre-plan, kenalah ada apa error yang kemungkinan berlaku. Sebab apa yang you buat ni adalah dokumen sebelum you involve, not really sebelum. Maksudnya memanglah benda tu tak ada error lagi, sebab you baru nak buat dokumen kan. Tapi you kena ada future thing lah. Okay, contohnya pre-plan, apakah error yang kemungkinan ada yang perlukan corrective action. So like example here, the question you need to fulfill, what problems might occur, what specific action should take place, who will be responsible for the action, and who will document the corrective action step. So you need to answer this question, then you can manage to do the corrective action into the Haccp plan. Alright, okay. Alright, so one more slide before I make into another part. Okay, I break down the YouTube video into 2 parts. The first part is the monitoring system and also corrective action, and then part 2 I'll make into the second part, which is the verification and documentation, step number 14 and step number 15. Alright, so last slide. Establish a system to correct each identified CCP. Okay, example here. So let's say CCP1, the critical limit is the LOG. Ini nampak tak dia potong. Dia sebab dia nak tunjukkan corrective action lah. Kalau tak nanti jadi besar dia punya dokumen. Tapi sepatutnya akan adalah table untuk monitoring tu. Jangan salah, jangan confuse ya. Ada sebenarnya, tapi ini dia nak tunjuk cepat corrective action dia apa. Okay, so for CCP number 1, hold product at appropriate temperature until valid LOG or COA provided by the supplier. Okay, so kalau kata tak ada LOG, so what should you do? Hold product at appropriate temperature. So barang tu, contohnya dokumen dia tertinggal, supplier tu tertinggal dokumen dekat office, dia bawa raw material je. So what should you do? You take the product, hold it in the chill room dulu, tapi jangan terima lagi lah sampai dia bawa balik the LOG or COA. So hold product at appropriate temperature until valid LOG or the COA provided by supplier. If not provided within 12 hours from receiving time, reject the raw material. Okay, that is example of corrective action. Yang ini kita sambung next part. For CCP number 2, cooking. Okay, so this is the critical limit above 90 degree. Okay, cooking time 30 minutes. So what happened? Example of corrective action, hold product at temperature below than 4 degree. Check cooker heating system. So let's say kalau dia kata deviate, instead of above 90, 70 degree. So what should you do? Take the product and put in the chill room, or hold the product at temperature below than 4 to avoid the temperature danger zone. So if cooker heating system adequate at stand cooking time, okay, kalau kata dah boleh baiki, and then you tambah lagi tempoh masa memasak, instead of 30 minit, probably around 1 hour, contoh. If cooker heating system fault, hold product at temperature below than 4 until cooker is repaired. Recook product until critical limit is achieved. Masak balik sehingga above 90 degree. Okay. Number 3, freezing. Okay, you need to freeze it below than -22. So what are the corrective action? Let's say ada deviate. So hold the product at temperature below than 4. Ask maintenance to check freezer refrigeration system. So if refrigeration system indicate at standard, freezing. Okay. However, if refrigeration system fault, kalau ada error, betulkan secepat mungkin lah. Kalau tak boleh, memang fault, hold product at temperature below than 4 until freezer refrigeration is repaired. Freeze product until critical limit is achieved. Okay, and finally, you can read here metal detecting. So hold rejected product and check for metal piece. Ask maintenance to check source of contamination and take appropriate action to repair or prevent it from happening, or discard all product contaminated with metal piece. So these are example of corrective action that we plan earlier or pre-plan. Maksudnya belum jadi lagi, tapi ini adalah langkah-langkah yang patut kita buat kalau tak fulfill the critical limit. Okay, so I hope you can manage to understand two things here today, a monitoring system and also the example of corrective action. So after this, I'm going to record the part 2, the step 14, verification procedure, and also step 15, the documentation. Okay, so thank you.